Hello. Data science has impact on virtually every industry out there. It creates new workspaces for the data scientists and helps companies to grow, retain their customers, and optimize processes. Thank you today for joining us on the first data science seminar of 2021. I was really impressed that so many of you took a minute to share your ideas of what you would like to learn here today. And I promise that by the end of the seminar, you will learn a great deal of how your fellow business professionals and data scientists apply data science in business. So today, we will have 5 presentations, 5 talks from our guests. And each talk will be about 20 minutes, and it will be followed up by a quick Q&A session of 5 minutes. In the end, there will be a 20 minutes additional Q&A question and answer session and panel discussion. So my name is Elena Sugis, and I will help you to navigate through the seminar and will be asking questions on your behalf. So let's start. Our first speaker today is Markus Limpus, who is a co-founder of MindTitan. And today, Markus will talk about how to deliver on 85% of your AI projects. So he will open us some new secrets. Markus, please.
So thank you, Elena. So let's start out with the presentation. When I came up with this really inglorious and self-ingratiating title, the source of the title came from the fact that when you read those articles, like from different consulting companies that report that everyone's trying to implement AI, but 85 to 90% of the projects are failing. So I figured we'll make a short list of our own projects and look at what the number is in our case. And because the number is so close to it, then we figured it's a good slogan. So, sorry. And what I'll be talking about is what I came up with when I was thinking about, like, why does that happen that so many projects in different companies fail? Because like when I look at how these are being implemented in companies that I have cooperated with or that I have been in talks with, then like when you think about it, it becomes kind of clear. So I'll go over a few things that happen sometimes with different projects and that you're not supposed to do, and what would be a good thing to do when you're really trying to solve some kind of specific problem and use AI for it. So who am I? I'm a co-founder and data science lead at MindTitan. Because I'm a co-founder, then I've landed such a convenient position that I manage data science projects and I do data science hands-on as well. So I have a reasonably wide picture of how it's done. What MindTitan does is we solve other people's problems with machine learning. So we are basically an AI agency. So we see a lot of different industries, a lot of different projects. By now, everybody's kind of realizing it that you have to use data science not in only high-tech companies like Netflix and Google, but kind of everyone to production and customer services is really getting on the wagon here. And here's a short list of people we have worked with. Recently, there's been a lot of Estonian government, which is implementing AI all across the board. Also some foreign governments and different industries, larger enterprises and smaller startups, all across the world. So first thing, the thing that I see the most is that there's an inherent lack of focus in the way that machine learning projects are solved. And there are kind of like 2 ways that we can talk about the lack of focus. One of those, I will not mention names or too many details about anyone I bring bad examples about, but it was, I think, a few years ago, we worked with a Nordic telco, and we're trying to do a recommendation algorithm for them. And it was really hard to get cooperation from them, in the sense that The data is really complicated. They've been generating data for decades, and it's not very well organized. Different people know about different parts of the data, and it's really hard to get any good information out of them. And in the end, when we managed to talk with some of the managers a bit more, and we realized that there were 7 projects solving the same issue in the company. Meaning that there were 7 different teams, either hired or internal, who were trying to do trying to solve this recommendation engine problem. And when you're trying to try out like different solutions in the market, that's of course good. Like you're supposed to do that. But in this case, what happened was that you didn't have a single product owner, but each of those projects were not like competing. Who has a better solution for some project owner's problem, but they were in essence competing internally with each other, and there was so intense internal politics in the company, trying to like show other solutions in a bad light or defund them. That essentially, when you're doing something like that, you don't get trusted. You don't get results that you can trust, and at the same time, you waste immense amounts of resources, and people don't like each other anymore. But this is kind of rare. What happens a lot more is that you don't. What people don't do is that they try to solve really large tasks in a single go. A good example of this is that we're working with an energy delivery company, and they have to do maintenance on the power lines. And they want to do it a bit programmatically, so there are drones that that fly over the lines and make images. You have to diagnose those images, like what's on the image, are they broken, in what way are they broken? But the thing is that like there are thousands, tens of thousands of kilometers of footage. It's a weird way to measure footage, but there you go, coming in like every month, you could say. So in this data, you have more than 10 types of insulators, more than 10 types of faults on each of the insulators. And that's like covering a single, not even a whole country, but that's like covering part of a country. So it can only get worse. So when we're talking about like more than 100 different classes of really small objects, if you look at the footage, these insulators aren't close. They're imaged from really, really like far away sometimes. So it's not really reasonable to like just try and solve the whole problem at once and only be I don't know, content with the result, or like find business application to it if it's solved all in a single go. So what we wanted to do here, what we figured would be good to do here, is that you select a few of those. In a sense, you take only, for example, the most common one, maybe the one on the rightmost one, and you start diagnosing that. And we started doing that. Of course, when you label everything, then you still label all the pieces of data, but you realize at one point that you get those little brown ones the most, you get the faults for them the most. So I think it was like with a few hundred labels per class, we started to be able to like detect all the objects. You can detect the cross arms, you can detect the posts themselves and all the insulators. You start with only the faults that you have a lot of examples about. Like some of those are common, maybe they're like completely trashed, and it's also simple to recognize, but you don't go after the really rare ones. So if you can find business application for this smaller part, do the smaller part first. If it works, you can move on from there. This is the goal parts. When you like an issue with a C with reaching goals, like there are a few issues here, and this is maybe the most depressing for all the data scientists or people responsible in the company. The first issue that happens there is that you don't even have real goals. It's kind of, it used to be more common. Now it's becoming more and more rare that you get some data scientists, give them a bunch of data and just tell them to find some interesting patterns. When we started out with mind typing, it was very common that this is what people asked, but this doesn't really take you anywhere. So yeah, it's a terrible way to go about this. And if you ever worked with big data, then you know with that, the complexity of the problem doesn't scale linearly, it scales exponentially. So a good example from this is, for example, that when we started the company, we started working with Elisa, and they have a lot of cell tower data, which is like there's a huge amounts of it being generated every day. And originally there was like no like immediate understanding of what we want to do there, but we didn't go to solve the problem immediately. We thought about the data a bit. We talked about everyone, all the like business stakeholders in the company, and realized that they realized, not us data scientists usually don't realize the business problems, that what's the most important thing is to understand how people are really feeling in the how experiencing the service in the company. So we took all these terabytes of data, and rather than going digging in there, which could take years and years and years to find any patterns, and in big data you always find spurious and completely unimportant patterns, we ended up with an index, which is, as you can see, like as a technical person does it, it's kind of in a reverse, that the higher it is, the worse the experience is. So basically what the index does, it says at every single point in time how a single person in the network is experiencing the service that they're getting, either watching YouTube or doing something more uncommon. And what this also is being used for, like later on, what it was also being used for is to understand how the network, like how people in the network over the country are feeling, how the network is working out for the people. And this also is kind of a tool to help you plan the network, plan the service. So how to like actually think about this in another way is that when you think about all the things that you can do with your data, think more from the business side, less from the data side. That what's the potential value of solving the problem, the difficulty of the machine learning problem, and also the urgency of solving the problem. Now, for a business person, the potential value and urgency, these are like relatively simple, or like you can think about them. But the difficulty may be maybe the more complex part. And if you don't know much about it, then you can always start with analysis. This is an interesting example. Because the Emergency Center of Estonia, they realized that what they need to do in the future is they need to analyze automatically the topics of the information line calls that they have just tons of coming in all the time. And they didn't really know how complex solving those problems is, and no one can like really tell you how complex solving a specific problem with a specific type of audio is, because audio is very varying, and it's difficult for a machine to understand what people talk about. So what they basically started a project where what they wanted was to learn from their data how complex different kinds of problems are. So when you have really sharp eyes, then you can read that they asked about like age, gender, language, sentiment, and a few more things, but because of lack of time, we couldn't get through all of them. And we could build such an do the analysis or write them up a document like if you wanted to do all these things, this is how hard it would be, how long it would probably take, and then you can put them into perspective, like which projects am I supposed to do at which time. Another good example is also again from Elisa is the whole customer service automation part. Like you do both chats and calls, right? This is basically requires understanding text, understanding audio, building a knowledge base. So it's an immense project. It takes years and years and years. So we see that it's very difficult, and not only from machine learning side, it's difficult from many different angles. But at the same time, its importance is high. Its return on investment is probably really great. And at the same time, also the urgency is really high, because bad customer service is a urgent and intense problem. And the other part with the goals that I see in companies sometimes, especially with internal teams, internal projects, is that there is no real internal pressure. In the sense that data scientists, like when you have the mindset that you give data to data scientists and tell them do what you want, then there's no real internal pressure in delivering either, or it comes suddenly when sometimes someone realizes that the budget is being overrun in some way. And this is kind of a management and motivational issue, and part of the management issue there is that people don't know how to manage data science teams. They don't know what to expect of them. They treat it as research in some ways, but at the same time, they forget that most businesses don't really support open-ended research, and it doesn't, in the end, work out for them. So they kind of end up being without results and relatively unhappy because the goals weren't aligned. And the last bigger one maybe is wrong team. And when I mean wrong team, I don't mean that you don't have data scientists, but I mean the setup of the team itself. So the mistake number one is hiring a data scientist. The key here is a data scientist. You have a lot of data science problems and you hire one of them. What it ends up with quite often is that you have large amounts of data, 10 people, 10 different problem owners who all have their different issues that they want to get solved. And you have one little data scientist who has to manage all their expectations and all the pressures that come with it. This obviously can end up in disaster simply because of the pressure, but also because of different skills, different expected skill sets. Because like when you look at, this is a small graph of emergency center assistant application. What we have to do here is that you have a helper that basically understands what the person on the line is talking about, tries to understand what the situation is, and provides help to the emergency center employee. And when you look at this, like this is what you have to build for it to work. These are the machine learning components. So we hire this single machine learning engineer or data scientist. This is what they can solve, and the whole system is what is expected that they would solve. So again, this is like in some sense, if you hire a data scientist without a team, without decent project management, without people to support them around them, and then you're not really going to get there anywhere. But it's still like it's something that's being done quite often. What a decent team would be like: you have a business leader, someone who handles the communication and can tie resources together. You have a problem owner who understands the problem itself from the business side and reasonably well the technical side, so that they can fix the communication dissonance between the parties. You have a data scientist who does what data scientists do. And also you have data engineers and the whole infrastructure team to manage the deployment of the machine learning models, because otherwise this whatever data scientists do, like they're usually not engineers. They will not be able to deploy it in any way that it is performant. An example of this, or when we work with the tax and customs work, this is basically the process we're covering. Like you have the data source, AI, analyst, auditor, and then the actual process of looking at these people with like high risk of fraud, for example. And when you think about this, then the only part where that the data scientists have any control over at all is the AI part, which is which is what we were working on. And so in every other part, we need people to guide us, to tell us about the data, tell us about the process, to tell us about the feedback that they can give and that has been given. What I ended up with was that there are total 12 people in every sprint call, and there are 2 data scientists. 10 people are basically either leading the meeting or giving information about different parts of the process. And this is kind of how it should be. 12 is a bit excessive, but like it's a big organization. When you think about the general machine learning process in general, then when you look at the processes like the research on the data, formulation of hypotheses, selection of them, developing and validating the model, and putting it into production, then there are very few steps here in which you can have only a data scientist. You need business people and people who understand the data in almost every part of it. Not to talk about project managers, engineers who can help with getting stuff into deployment and so on and so forth. So if I have to take it all together with a few takeaways, then I would say that there are a few of them. First is to understand your own focus, like what you really want to do. What is the smallest unit with which you can generate business value? Solve that first, move on from there. The other part is that data science is research and engineering, which means that although you can treat it in some sense as a research project, it's also heavily, the deployment part, the applied data science part is actually heavily an engineering field. You can't do it without either machine learning engineers or a well-integrated engineering team. And it also means that it has to, in some ways, not in all ways, but in some ways, it has to be managed as an engineering project, not as an open-ended research project. Go and do what you want. When faced with the unknown, people forget their own standards. What I mean here is that that you have a project manager, but when they don't understand what the data scientist does, what the data scientists, what their goals are, what they're supposed to do every day, then they kind of let go of this whole agile methodology or waterfall or whatever they've been using, and they just kind of like retreat and they don't really manage it anymore. And then you end up with a situation where you have no real internal pressure or checks on where the project is really progressing. And also remember that it's a team sport. It won't be done by a data science team that is isolated. Data science teams have to be in direct communication with all the parties who are in any way tied to the execution of the project. Thanks.
Thank you very much. It was a really cool presentation.
Thank you.
I hope that for everyone it was very useful. And guys, I forgot to tell you that you should forward the questions into Q&A window. So if you have a question about the talk, if you have some technical issues, then drop the comment in the chat. And we have a couple of questions. So first question is, how thorough will a problem owner have to validate the solution provided by the data scientist?
Well, I think actually the problem owner will not only have to validate it, but the problem owner will have to actually guide the process of how to validate this. Because data scientists will give you numerical metrics. They can tell you what's the precision, accuracy, and recall. But they will not be able to tell you what does it mean in the context of the business case that we're solving. Does it actually does utilizing this application actually save people time, save the company money? Like these are something that only the product owner knows and can come up with. So,
okay, so the business metrics are coming from the other side.
Yeah, it's like during the process of development, the data scientists will be reporting their accuracy. They will discuss which is more important, precision or recall. But in the end, like what you're really validating the system on is like, is it making people's lives better or not? Is it solving the actual use case? And this is something that only the product owner can even tell you.
Okay. So we have one more question here is how we can improve medical system by data science?
Oh God,
can you comment on that? Because you have a range of various projects, and so maybe you can comment on this problem as well.
A range of data science projects. I don't have a range of healthcare projects. I'm not sure I really can comment on it because, like, as far as I know, then even those low-hanging fruit like radiology picture analysis and so on, they haven't actually been pushed to production. So there must be something there that's keeping it back. I won't dare to answer that question. Not wise enough.
Okay, but you mentioned some low-hanging fruits. What do you think is the easiest to implement, like where to use data science in the company, in the majority of companies? So what can we solve? Which kind of problematics we can solve using data science?
I think information retrieval is the most common one. Because like information retrieval often is very well developed. For example, you want to build a tool which helps you compile documents or find documents or find pieces of information. Like in a sense, it would be like a semantic search. Semantic search is something that is easy to build inside a single company when you have like shared data sources. Then and the technology is well developed enough that you don't have to be don't have to hold a PhD to actually build one, and you can build a proof of concept quite easily. So I would say that this is the lowest hanging fruit, but it depends on the company again. I was recently approached by a timber company, and for them, it seems that the simplest thing would be that you have a small camera that checks the pieces of wood for rot and other defects.
So we have one more question, and I think I will let you go. So please tell the role of data cleansing in enhancing the quality of data.
The role.
So how much you have to? Probably it's the question.
How much I have to do it?
Yeah.
Heavily depends again.
And what do you call quality data as well?
Yes, also true. Usually the worst quality data, like where you have to spend the most time on this kind of process, is where you're given a legacy database, usually in Oracle, and it's been filled with decades of data, and you have to understand what's even in it. Then the part, like you can have a project that takes a month of data science and 4 months of clean data. I've had this experience, it was terrible, I wouldn't like to do it again. But if you're working with, like, for example, images, then it's a lot more easier. I mean, you have to collect the data, label it, but there's no like cleaning in it per se.
Okay, Thank you very much.
Thank you.
Thank you. I will. So our next speaker is Kalev Koppel. He will talk about hired or fired by AI. Kalev is the CEO of Stack.
Is it on?
Yeah.
All right. Hello. My name is Kalev and I'm coming from Stack. I was under pressure of choosing the title for this presentation, so I just come up with this get hired or fired. But today I talk about actual use cases where Stack is helping our customers to make use of AI and get ahead with the business. What is Stack? Stack is a data science company, and we started already 12 years ago. What makes us unique is also academic and research background and very close cooperation with Tartu University. And nowadays it's been mostly around personalized medicine. But our business lines are growing gradually in recent years, and we have 40 people, and it's a good combination of both research and industry competences, including all these roles what also Markus was telling about in the company. Yes, it would be obvious to talk about something about recommendation systems and chatbots and all these more major AI solutions, but today I decided to avoid and skip because maybe it's too boring. Anyways, we are, and Stack is the main provider of recommendation system for big Estonian retail companies, and including Coop, Kaubamaja, Selver, Magnum, and we analyze the purchase records, and maybe you receive sometimes campaign emails. Sorry about that. We are behind that. But I selected a few use cases where data science is in help of getting ahead with the business. The first use case is how AI helps to pay taxes or calculate taxes. And our partner or customer is one Estonian startup, Aurora. What they are doing is intelligent cross-border compliance platform for and providing critical services for postal operators, e-commerce platforms, authorities, tax authorities, logistics providers. And where's the problem? The problem is external, and it comes from the regulations. This year, from July, the VAT 2022 euros exemption will disappear. What it means, whenever you are ordering something from Chinese e-shop, you have to calculate also now VAT tax on also, let's say, mini plastic bag. And it changed dramatically the situation on the e-commerce. So this company is trying to solve this puzzle, not to mention Brexit and this what now brings on all this international trading. And of course, there are thousands of regulations and exceptions. In this slide from Aurora, you can see that even printed books or mobile phones have different VAT rates in different EU countries. However, how it is enabled? In the center of this type of systems, there is something called HS code, and HS code is basically the international classifier for products, different products, and it allows countries to classify traded goods on a common basis for customs purposes. Fine. And this code is hierarchical ontology, and it contains, even on this very level, we are approaching it over 3,000 different classes. And our task here is now to put together or classify the products based on their product descriptions, let's say in eShop, to this classifier or this ontology. And sometimes you maybe know that these descriptions can be very, very confusing, and now we tackle this. Let's say even the products like tank top, T-shirt, or whatever might be confusing, and how to teach it to the machine. So a lot of natural language processing, different neural networks algorithms is tested in this project. This is the main job of ours. And also non-functional requirements are high. So whenever you are making the checkout in the marketplace, we have 100 milliseconds actually to allocate this HS code and calculate taxes and to enable actually this type of transactions there. Yeah, and specifically Stockholm is more, not less, not more than to build the best AH code classifier in the world. That is something we need to do. Another use case is about food safety, and we use AI to generate safety instructions for the food companies. And our customer here is a strong Estonian startup company, Food Docs, and they are into the business to make our all this process and actually to provide safety in the food business. You all know the corona is high, but we had this listeria crisis. We now and there we heard about salmonella stuff, and there are a lot of regulations in this food business. Whenever you touch the food business-wise, you have to fill in something called food safety plan, and there is food safety. It's called actually this HACCP, which means hazard analysis and control points plan. And normally it's very complicated stuff. It takes really a month to fill in properly. And Food Docs really helps their customer now to, their ambition is to help them to fill it in within 1 hour. And just giving you an example of how complex this, there are a lot of regulations. Again, we are in this murky world of different regulations, global, regional, country-specific regulations. And this language there is also very complex. For instance, maybe you know what is emulsion sauce, emulgeeritud kasta in Estonian. It's mayonnaise, and they have to go through it. And there are hundreds of fields to fill in this regulation, setting up this food safety plan. And if it's up, also monitor the process in the food company. And where we come in is to, the solution is use AI to generate or predict the answers based on existing entries already. We profile the company. It's a type of recommendation system to help them go through this process. And that's the right solution, and AI is very useful there. So we help to onboard their customers and also help to monitor their business processes there. The third use case I'm telling about is one of our internal projects. We are cooperating with Limpus Eesti Aktsiaselts and also Selver. And I think all the retailers, their ultimate dream is to predict accurately the sales, future sales. And that's what we are doing based on the historic sales. And the purpose of it is to avoid out of stock or overstock, reduce waste, cut the ecological footprint, all good. And some early results of this project is that now we are, this is on the shop level, on the SQA level, we try to predict all the single products there. This example is about coffee, one sort of coffee, Paulik, classic filter coffee there. And these gray areas on the diagram are the campaigns. It really works better. And we are now more accurate that their baseline was, which were actually very simple, the average sales in the last 6 months. On the most of the categories they are better, slightly better, if you see the diagram, 10 to 20%, but it already has a major impact to their business because the volume is big. So I think it's enough of the business. It's not all about the business, even your today's main topic was the business. But we also try to satisfy the curiosity of the people and also entertain people with the help of AI. This use case is about detecting or identifying the birds based on the voice samples of the birds. And the company is Laponica OÜ, Estonian company. Their main market is not in Estonia, but in UK, in United States. And maybe you remember that recently there was one Estonian-based application for that called Suits, which were detecting the Estonian birds. But our market is different. And this very bird, Limosa laponica, which is also in this picture, is actually the world record holder of long-distance migration. This bird can fly really 15,000 kilometers from Alaska to New Zealand each year. Maybe it reflects the ambition of this company. But non-trivial fact is that not for the data scientist, but maybe for the rest of us, is that that the voice analysis is not the computers can't use the voice, but it is converted to pictures. The bird song is or this voice sample is are transformed into the frequency power spectrograms, and these will be fed into machine to learn the patterns there, and to use already the algorithms and neural nets dedicated to the image classification. And this picture is about this tomtit, or what's the bird in English, rasvatehane, first 4 seconds. And so in this project, we tried out very different open source algorithms already available, selected one of these convolutional neural networks, and then fine-tuned it and reached to the good results there. And it's now birds in UK, not in Estonia, right? And audio samples came from the big database xenocant.org. It was the fun project. And here you see the team of our team at the Laponica project. And I think they tried to confuse the system with some polyphonic sounds, I guess. So, and my last use case is also about, it's from the different area. It's about how to write plays with AI. And with Tallinn University, we had a joint project where we, based on Anton Chekhov's plays, generated the new play. And their ambition is, in future, is further that they even use AI for generating the stage design, and even have the actors and actresses are robots actually playing the plays. And we had there We called this AI John, and John had different tasks there. The students were helping to annotate the text, and later on we generated, actually it was based on the big English language model, GPT-2, and fine-tuned with help of this plays, Chekhov plays, including Three Sisters, Seagull, etc. And so we have now the text, and we have to move on with going to the stage, I guess. And that's the end of my presentation. To just make reference to the title, I can answer that nobody got fired, but AI really helps to enable global trade. It helps to go through the complicated business process, such as setting up food safety plan, for instance, or AI just can help to reduce waste in retail or in stock. But AI also could help satisfy our curiosity and learn about the nature, or just helps us to entertain us. So thank you for listening to me.
Thank you very much, Kalev. It was really cool. Actually, I enjoyed the variety of topics, and I'm actually amazed that you're doing so many different things and stuff.
That is our main problem. We have two different things to tackle, and it's really hard to choose. But our approach is that we will have the more solid business lines of doing harnessing AI, but also we purposely choose some fun topics for the data scientists for them to learn more new stuff, and also sometimes they get bored doing another recommendation system, you know. So you need to.
So you have to be creative.
Yeah, actually, yeah.
Okay, that's pretty cool. So we have some questions here.
Yes.
First question is, can the product demand prediction system also consider major disturbances like coronavirus pandemic? So you showed some demand prediction.
Yeah, it's a especially good question. In this type of systems, you can basically select a period, but I think this kind of you need to have a good history of these events to train the system properly. And coronavirus was definitely the event which changed really the retail patterns there. And if you don't have the durations of similar situation in the history, then you basically can't make the system which really could predict what is going on. Mm-hmm. So the simple answer is that no, we don't have such an history. But basically we can control the situation and choosing already, taking into account already the patterns, what has happened already. I mean, I don't know. It was even we can use even secondary data sources such as weather and some maybe macroeconomic factors to combine. But it's a really tricky situation, and that's why it was a really good question actually. Straight to the bullseye, I would say.
We have even more popular question, which is kind of connected to the previous one, and it's tricky. So how can a model that is based on the past data possibly predict something correct in the behavior of some data source radically if data source radically changes for the reasons that cannot be known in the past? For example, like why can nobody accurately predict the next big crash?
Yeah, no, it is really philosophical one as well. Like, I think the trade-off of a predictive system is that how long is the history, what you take into account when you are predicting, and how long you have to predict. With the weather, it's really easy. With the example of weather is that without any model, you can easily say that the day tomorrow will be 60% of the same what is today, right? But if you make it longer, the accuracy will decrease dramatically. And And I think this type of systems, you really would follow what are the trends already, and you could extrapolate these trends there. But yeah, I can't. It's too complex question to answer in one, I don't know, 10 seconds or 1 minute explanation. Yeah, but it's a good question. Thank you. Thank you for that.
So we have one more question. Will AI eliminate human interaction completely?
No. Why? You mean what kind of interaction? You mean communication or sexual or business interaction? It would never eliminate it, I have to say.
But which jobs do you think in the future, which sectors will be affected the most?
No, I mean, what you can automate, and these type of sectors will decrease. All these manual work, even what we are this annotating text, for instance, or some, I don't know, profiling of the customers based on some data sources will be automated in the future. But I'm very optimistic saying that we free up the resources, brain power to more complex problems, and these people could do much more in other areas, maybe even controlling the system or validating the results of the system, and so building these type of systems better and better gradually.
Okay.
Okay.
So you're a company of data scientists. So
yeah.
Which kind of education do you expect them to have when they enter the job?
Actually, I have to say that we are average software company nowadays already, and we are a software company. I think even more than 50% of our work is actually made by data engineers, building automated data pipelines and software there. We have front-end developers, and data science is only the part of it. And the best employees of ours are actually not only focused on the data science, or pure data scientist is not needed in this type of business anymore. It's needed very much, but the real stars in our company are the people who can cover both, do the software development and be good at the data science. And we try to let's say, not to build borders between data engineering and data science whenever possible. Of course, there are some very specific areas where data science can focus on this specific area and the business domain and can make use of it. But yeah, in average business projects we have, the more flexible people are, the better. I mean, if you compare data engineering.
Wider range of skills.
Yeah, wider range of skills, and this specialization purely on the data science, I think it's not the future where we should go. Maybe we are still too small, and maybe are searching for the possibilities, but that's the case at the moment.
I see. I'll ask one more last question. So we quite often get some comments about whether data science can be applied for small businesses, and micro businesses. What is your comment on that? Will there be is it beneficial for them compared to costs that they have to invest into?
No, it depends very much on the use case. I think we are working a lot with the small companies and startup companies. They normally are very small at that very moment we start cooperating. But I think what has been changed in, I don't know, recent 3 years, 4 years is that nowadays everybody is talking about this AI. And they already know about it, which is also good. They know what they're talking. You don't have to teach them anymore, because I think the government, the university, everybody has done a very good job of explaining what it is. And they have now much more realistic expectations towards the AI than it was, let's say, 3 years ago. So you can start actually doing job with them. But small businesses, yeah, now it's, I think, too general. You need to specify what is meant there to properly answer to the question.
Okay, guys, if you have some more questions about these topics, just post them to Q&A, and we will address them in during the panel discussion. So thank you, Karl.
Thank you. Thank you very much.
Thank you very much.
Yeah.
Thanks. So our third speaker is Professor Marlon Demas, who is from the Institute of Computer Science. And Marlon is a data scientist, and he thinks that in business, everything is allowed except doing some illegal things and not improving your business processes. So in this talk, he will talk about business process mining. Welcome.
Right. So I'm going to talk about process mining in practice, how it affects businesses, how it is used for businesses. And as an introduction, I'm going to take a character that I'm going to carry through the whole presentation. So the character's name today is Taivo. And Taivo is a customer excellence manager at some company that sells stuff to various customers. Tom is at the heart, business person, cares about customers, cares about recurrent sales revenue, cares about efficient service delivery, and all sorts of different things. Every week or every month, Taivo has a different challenge, a different set of questions to address those challenges. One time it is, why did the churn rate suddenly increase last month? Why did we have less recurrent customers, repeat customers? Why did the number of customers complaints has been rising in the past month? Why is it that our response times for customer complaints has gone up, even though we just hired a few new people 3 months ago and we have trained them, and we thought that by now we will have our customer handling times in a better shape? Why is it that our response times why is it, what should I do about it? You know, where does the problem come from? And Taivo has a lot of choices to make. He could automate certain parts of the processes for serving customers. He gets every so often some vendor, pushing some technology, for example, a chatbot, to handle some of the customer inquiries and try to filter them through. Or he just saw this co-browsing platform, a few weeks ago, where salespeople can, start connecting with the customers while they are browsing on their website. So that's Taivo every day. At the same time, on the other side, there is a bunch of information systems that are maintained by an IT department. And those systems have a lot of data that can tell you a lot of things about what Taivo is asking. Your customers' website visits, they are there. Your customers' orders, they are there. When did they arrive? When were they served? When were they shipped? When were they delivered? Your customer complaints are somewhere there. The activity of your salespeople calling out on customers is all there. Not all there, but some of it is there. The activity of your customer service staff is there. Your shipments, your product returns, you know it. It's in different systems, but it's somewhere there, out there. So it's kind of frustrating for Taivo to be having all these questions on the one side, and on the other side, in these immaterial information systems, it's lots of data that could answer potentially those questions. And I think one of the biggest frustrations of business people with data science is that the data is there, the data science is there, and the business science is there, or the business need is there, but connecting all those dots is a little bit difficult. So Taivo has a few choices on how to bridge this data with his problems. He can hire a data science or AI consultancy company that delivers successfully on 85% of his projects. How cool can he get? That's really good. So it's a nice option. It's a very tempting option. It's a very useful option when Taivo wants to address specific challenges, like when he has committed, no, we should bring in the chatbot, and getting the chatbot in, we should hire this 85% successful company. But it doesn't solve Taivo's problem like, okay, today is Monday, and I'm just looking about data from my performance measures from January, and I have a problem. I cannot call the 85% successful data science company every Monday, asking X, Y, Z. It's not really how it works. he can hire one of those data scientists or AI scientists who has not yet been fired by AI. So we just heard about some of them. So it's nice if you can, you bring in your data scientist. However, the data scientist brings in the technical expertise, not the business expertise. So you create a certain disconnect between, like, Taiwo having these business questions, asking it, getting a data science team to work on them for 2-3 weeks, by which time Taiwo has already moved to something else, and coming up with very sophisticated answers that are sophisticated from a technical perspective, but that do not take necessarily into account the full spectrum of business requirements. Sometimes the problem is to spell out those requirements. Taiwo doesn't really know what he needs to ask. But if you get one of those data scientists, of course, grab them. Now, there is another option, and that's the one that I'm going to talk about today. You can set up a self-service system that allows Taiwo to answer the questions he got by himself. That is kind of a little bit like the nirvana. So sure, when you have a specific challenge that goes beyond, what you can do by yourself, you tap into the data science teams, you tap into the consultants. But when you have your everyday question, you kind of want to be able to answer it yourself. So process mining is this emerging technology that allows you to bring self-service, data-driven process analysis into your desk. So the whole idea is, there are nowadays, with the level of the digitization we have in companies, and especially companies that are using relatively standard type of systems out there, like CRM systems or ERP systems, there is a lot of data in their system that can be collected in a relatively standardized manner and put into a certain format, merged into a certain format by means of a data preparation pipeline that will put it in a shape that makes it suitable for self-service process analysis, in particular using process mining algorithms. And of course, process mining is not the only technology out there. Of course, there are other tools that are trying to do that for, on the customer analytics side, on the supply analytics side, etc. But process mining is one that focuses specifically on Taiwo's process problems, problems that have to do with things getting stuck in the middle of the company, like customer complaints getting stuck somewhere in the middle of the chain. And the whole idea of process mining, at the essence, is the following. Whatever information, whatever data you have about your business processes in your customer relationship management system, in your enterprise resource planning system, in your ticket handling system back there, or all sorts of other systems you might have back there, most likely can be put, if it's about a business process, it most likely can be put in the following form: a big table that somewhere tells you that every row tells you that some activity happened, like a customer filed a complaint, or we replied to a customer, or that we returned a product to a customer, a customer returned the product, or we shipped the product to a customer, or the product was delivered. That type of things that tells you what happened. Some sort of timestamps. Nowadays, systems are pretty good at recording when things happen. Your typical ERP system is timestamping pretty much everything that is happening in your backend. And a case identifier, this is a bit of the tricky one, but you will often find it, is an identifier that tells you what process instance are you talking about. If we say we are talking about a customer complaint handling process, well, the customer complaint ID or the customer ID will do the job. If we are talking about a process for handling purchase orders, the purchase order ID. If we are talking about a process for handling invoices, the invoice ID. So that kind of business object identifiers that you will find in your information systems will allow you to relate events that happen in your system to instances of a process that you care about, like, for example, your order to cash process, or your quote to order process, or your customer complaint handling process. And then you can have a lot of other data depending on the system you have. You might know, for example, who did which task. You might know some data about like the amount of the purchase order or the number of items that were ordered or whether or not the purchase order was returned, the products were returned or not. You might have a whole bunch of other columns. And the whole idea of process mining is like, if you have those columns, just plug them in, right? As much as you want. And using that kind of tables or data frames, you know, process discovery is like gives you a set of tools that by click and pointing allows you to do at least 4 operations. The first one is to automatically discover a map or a model of your business process, which allows you to see, you know, what are the pathways that you are taking, and perhaps more importantly, which pathways are going in the wrong direction towards a customer complaint and which pathways are going in the right direction. So it allows you to generate visualizations with various semantics that allows Taivo to understand how the process looked like and how do the bad cases look like versus how do the good cases look like. Secondly, it allows you to identify deviations with respect to how you like your process to do. So it allows you to sketch. This is how my process should look like. This is how my happy path should look like. Now, tell me, when am I deviating from this happy path? And among those deviations, which ones are causing some negative outcome for me? Like, for example, product returns. You know, what are the deviations with respect to the happy path that signal that I will have a product return or a customer complaint? The third thing that it brings us is the ability to understand, to trace down the performance of the process down to the lowest possible level of specific steps. So, of course, you might know that your response times, you know, from the moment you get a complaint to the moment it's resolved are very low, are very high. But what you want is to know where exactly does that come? How do the different phases and steps in the process are contributing to this slowdown? Where are your bottlenecks? And process mining allows you to, in a way, overlay in different ways performance information on top of process maps so that you can trace your performance problems, your process performance problems down to individual elements in your models. And that you can relate those back to your typical performance dashboards, you know, and you can see the relation between trends in your performance measures and what is happening in your process. And finally, and perhaps foremost, it allows you to compare multiple variants of your process. For example, if you are running the same process in 2 different cities or in 2 different countries, and in one city you are doing well and in the other not, or in one country you're doing well and the other not, it's kind of very useful to identify the positive deviance in your process. Why is it that you are doing better in one place than in the other? Or vice versa, if you wish, the negative deviance. Although in general, we prefer to work with positive deviance, you know, because it's more constructive. You can go and tell to the people in city A, hey, city B is doing a bit better, and guess what? They are doing this and this differently. And then city A might take it constructively and say, yeah, maybe we should do the same. When you do it in the other direction of negative deviance, you know, people have a bit of reactions to it. So by means of comparative process maps or comparative dashboards, process mining allows you just with clicks and pointers to get that type, to answer that type of questions. Where is my positive deviance or where is my negative deviance? And this is a technology that has reached a certain level of maturity, and that's what makes it very exciting, that has been tested across different industries. So no matter which industry you are, financial, healthcare, industrial, public sector, consumer services, you're going to find examples of companies like yours that have already implemented process mining in some way, and where managers are actually using it in practice. It's also not a technology that is confined to large companies, although naturally large companies can benefit a lot from there because there is a lot of untapped value, untapped potential behind their processes. But also smaller enterprises are using it, particularly when smaller enterprises that are relying on relatively standardized systems, like, for example, if you are using a ServiceNow system or a Salesforce system or a ServiceNow system or a Microsoft Dynamics system, it's kind of fairly standard to connect your system to the process mining tool. Therefore, the setup cost is low, and you can still benefit from doing process mining, from setting up process mining to answer your business questions. Here at University of Tartu, in conjunction with our partners in with Apromore, a process mining company with which we partner, we have conducted a number of engagements. For example, we engaged with a financial company in the Nordic countries, a mid-sized Europe payment systems provider, where with their customer service team, where they wanted to improve their customer onboarding and their customer support and renewal and maintenance processes. They had some problems in terms of customer satisfaction, where in some countries they were performing less well than they wanted. But fortunately, in other countries, they were performing very well. So by tapping into data from their subsystem and from their ServiceNow system via their existing data lake, we managed in a matter of weeks to analyze their customer onboarding processes and to identify these positive deviants, these practices that were helping them to have much better onboarding times in some countries than in others, as well as their negative deviants on the other side. And this led to a certain number of implementations, which after 6 months had a visible reduction. It led to visible reductions in the onboarding times and reductions also of rework loops, increases in Net Promoter Score, etc. And what is interesting here is that it's not a one-off exercise. By setting up the data ingestion pipeline into the process mining tool, now the analysts inside this company are able to conduct this analysis themselves. Business analysts conducting this analysis themselves on an ongoing basis in order to, preempt problems and to be able to tackle problems in their customer onboarding and service processes in advance. We have also worked with in other areas, for example, with an Australian insurance company trying to bring up their times, their claims handling times down, with an Australian pension fund identifying also inefficiencies in their pension claim processes, trying to find out bottlenecks that were preventing them from serving their customers fast enough, and identifying areas where they were not complying with respect to their own internal regulations. And we identified, for example, that although about 80% of their pension claims were following the happy path, there were a certain 18% that were not following them. And what's interesting is that this 18% were following 450 different paths, which we managed to classify and to come up with patterns that signal deviation with respect to their happy path, their main pathway, and to come up with ideas on how to prevent process instance from deviating from the direction that they were normally set. So by that, identifying, for example, rework loops that could be avoided, tasks that were being skipped and that later were causing problems, etc. And that lead to a significant increase in the efficiency of this process and the delivery times. We have done similar engagements with different other companies, not only in the business sector, but for example, in the field, in a supercomputing center in Italy, helping them to analyze their change requests, incident management, help requests, fault handling requests extracted from their ticketing system, from their help desk ticketing system. And by there identifying certain back and forth, for example, between teams that were causing frustrations to some of their users. This is just a small sample of to show where process mining is being used. This is the process mining database applications from 2020, which shows a very strong use in Central Europe in particular, and a pickup in North America. And Estonia is still trying to catch up, but I'm pretty sure that next year there are already, and we're already working with some Estonian organizations, at the moment confidentially, but this will be published later in the year, that are already deploying process mining to continuously analyze their business processes. Thank you.
Thank you, Marlon. Let's hope that all the companies will follow their happy path.
There you are.
only happy path. So we have in the chat, we have some questions for you. The first question is, do such process mining frameworks deal with prediction of outcomes of possible intervention?
Yeah, yes, there are. Just to name, a Promore has a predictive monitoring engine where you can use it to create predictive dashboards. You have to be a little bit, you have to separate the process mining as a tactical management tool. So you are an analyst and you want to kind of understand how to change your process, you know, how to change your rules, versus process mining as an operational tool. And very often the bottleneck for using predictive monitoring is that it's like an operational management tool, and it has a fundamental impact on the way you run your processes. I can generate predictions for you, you know, I can generate recommendations for you, but do you realize you have to change the whole way you run your process? You will have to mobilize resources to do something about those predictions, to react to those predictions at runtime. So we find that the difficulty of using the same process mining techniques for online predictive monitoring is the fact that the businesses need to change the way they run. The businesses need to become predictive at heart.
Okay. So the next question is that a bit connected with the previous one, that what would be your practical advice to start process mining in a small company? So basically, if you're a manager in the company, where do I start?
Well, I think that process mining, it depends on the size, but if we really talk about a small company in the sense of like less than 50 employees or 50 to 100 employees, my first question will be, for this to be useful for you, you will have to have a cheap way of getting the data out of your systems. Because that's the problem. Yeah, sure, you can get benefits, and I can imagine what magnitude of benefits you can have in that company versus the cost. And the biggest cost is building the pipelines to get your data out. So the bad news is, if you have custom systems or systems that have been like just, you have just amalgamated 4 or 5 or 6 different things to run your processes, I think you first need to kind of get those IT systems a little bit cleaner there. Because building pipelines to extract data from there automatically, periodically, is kind of relatively, is a bit of an investment. Now, if you use like standard systems, then it's pretty good. We are working with a lot of ERP vendors, for example, like an ERP vendor in Germany called ProAlpha, which has developed a standardized pipeline from their ERP system to the process mining solution. And now they have a repeatable pattern. So they go to one customer, and they are small companies, 100 people, and they say, we can analyze this and these problems and fix this and these problems, and they solve it. They continue going, moving to another company. So if you are using a standardized system, you can. If not, it's a little bit tricky. So,
and one last question, then I will let you go. So at the beginning, you mentioned that you can analyze highly standardized processes, in example, in CRM systems.
Yeah.
If you have to characterize the type of processes you can handle with your approach, what characteristics must those processes have with regards to quality, quantity, and variability, completeness, and so on?
Yeah, I think several of the characteristics you mentioned were characteristics about the data.
Yeah.
You have to have it's not so much a process, because I have seen process mining being used for pretty much any process I can think of. But the characteristic is like, do you have the steps in the process recorded in such a way that there are timestamps associated to it that are accurate? Like not like people record things 3 months later, in bulk. That is fairly complete, as you say, and that it has a sufficient richness of data, that you have some data attributes that allows you to relate the instances of your process to your business, like from which country this comes from which type of customer it comes from, etc. So those are the characteristics. I think it's characteristics of the data you have more than characteristics of the process itself.
Thank you very much. I think we're done for now with the questions.
Thank you.
I remind you, just in case, if you have some burning question and you haven't asked it yet, so please keep it, write it down, or post it right away to the Q&As, to our Q&As, and I will ask it later during the panel discussion. Okay, our next speaker is Professor Jakvila. He's the head of Institute of Computer Science and Chair of Data Science in the University of Tartu. And Jaak, in his talk, Supply Chain for Data Scientists, will explain how University of Tartu has introduced AI and data science into existing curricula, and also about the new data science curriculum and specialization. Welcome.
Thank you, Elena. So I will change the topic from the standard businesses to university business, which is business in the people, in the training of the people. Because as we heard from the previous presentations, then it's data scientists, AI specialists, business analysts who do the work and whom we so desperately need. How do we teach students what they need to learn in order to perform in their future lives? So what data science often is about methods, typical methods, typical data representations, analysis methods, AI methods applied in some context. And what is very important to understand somehow is that the method developed for one context can be very often applied in the new context, in the different field. So in the data science or IT in general, it's very often that we change field from one to the other. The illustration on the background, for example, in here, you can think of this representation of the data in your domain. It could be social network, trying to identify the influencers. It could be a social network trying to identify where are the, I don't know, the coronavirus spread, how does that spread in the social network, where are the fraudsters, or it could be proteins in the genome, in the human cells. It could be drugs acting for maintaining health, which drugs are similar, what are the relationships between different entities, distances, and all kinds of characteristics about these objects. Be it customers, churn, etc. So we need to analyze this data. We need to represent the data in different ways. There are tons of different ways how we can think of the data. And of course, the data is telling us about the past, like we heard in here, that we try to understand what just happened last week, try to understand data, or try to predict something new. So how can we, based on the past data, predict new situations? Something where we have not been yet at all. So this is, very broadly speaking, important in data science, but I'm very happy to hear from all the speakers before that actually we need more than just AI or just data scientists knowing one algorithm. We need more complex engineering skills and business skills to apply this kind of data science. Luckily, these are one of the KPIs of our institute at the University of Tartu, how many students we are currently teaching and educating. So as you can see, there has been steady growth in our computer science institute across the different curricula. I will introduce a little bit the curricula as well. And this shows that there is both demand for these kinds of skills, there is interest for these kinds of skills at different levels, and the output of this education is pretty safe also in the job market. Our main education is in computer science, and we have just one bachelor degree program called computer science that teaches programming, databases, software engineering skills, the basics of computing, and how to develop software. But then on top of that, we have the 2-year master's degree programs. And we have several of these programs. In bachelor's, we are now currently taking in 200, 220 students. And in master's, we are taking quite a lot more. So well above the master's level, shown in here, the main programs, software engineering, how to keep developing software, but also in the software engineering falls the business process mining, for example. You can see that in the software engineering, nowadays, you need to have the data science skills in order to produce business software. In the computer science, there is theory, also theory of AI. In the computer science degree program, we have AI specialization module. So that's where you learn deep learning models, algorithms, data structures, efficient coding, all these kinds of topics. And then we have brand new data science curriculum that I talk a little bit more, where we opened last year the first intake. We had over 60 student intake, and this year we are even increasing it further to 75. So this is a curriculum where we expect students from different backgrounds to enter this field, whether they have some business or some application area background from other bachelor degree programs, and then they want to learn the data science skills, or they have computer science background and they want to learn the data science skills together with the business application areas. We are also modifying this year strongly the conversion master's program. This is a session-based. This is a degree program where you can participate from your current job. Every other week you have courses in Tartu, or now the remote education is happening anyway. So conversion master assumes that you have previous higher education degree, be it bachelor's or master's, and you are working in some area. So it's so important that you have some backgrounds, some area which is your business, and then we teach all the IT skills, not all the IT skills, but we teach sufficient amount of IT skills so that you can perform better in your work. You can actually order software, you know how to make a contract with a data science company that does 85% of the success rate, and possibly help yourself with the skills of data science. And last but cybersecurity is a program where Taltech handles the intake. So this is a joint degree program with the Tallinn University of Technology. So in there, you can also imagine that in order to understand security aspects, you may need to do the intrusion detection or analyze your systems, discover faults in there. So data science needs skills would be also useful in there. So cybersecurity and software engineering are our joint degree programs together with Tallinn University of Technology. These are international programs taught in English, as is the computer science. Data science and conversion masters are for local market, so they are in Estonian, although quite a few of the courses, of course, will be also delivered in English. And then there are other curricula that, for example, teacher education, etc. So 220 intake at the bachelor level, and all these combined, I think it's 270, 280 intake in these combined degree programs, although cybersecurity is at Taltech. So each one of the programs is over 50 student intake. What we stream is to give this sort of pie type education in here, to have the broad understanding of the methodologies of the data science, main principles, presentation skills, understanding the business value need in broad sense. But then when we have the data science pillar, then we know that there is engineering approaches, big data approaches, implementation approaches, and the AI, more AI specific things. So at least in one of those, you should better have the deeper understanding, either in engineering approaches or AI approaches. But likewise, very important is that you learn to apply these skills in certain application area. And business analysis is one, understanding the businesses, be it the retail or be it the insurance companies or finances, understanding the business side is important. Different, you may think, is life science when you talk about the healthcare, bioinformatics, or natural sciences more broadly. Software engineering, there are tons of different ways how you can apply data science in your software engineering, or cybersecurity, for example, I did mention. So you should have some deep understanding of at least one engineering or AI area, sort of like methods understanding, but also go to some extent that you have gone in one application area, deep dive into one application area. Once you have done that in one application area, it's much easier to go into another application area, because these often are kind of transferable skills from one to the other. You apply the same patterns of deep dive in one area and the other area. Now we kind of heard that path to success is not always linear, because you may need to take iterations. You have some methods, you have some application areas, you have business value, business demand. The path is not always linear, but you can, with the skills, you can go and do your research and get the success. And in future, maybe you can also be successful in, hopefully, 90% of the projects. So I don't know how much detail I would like to go into the curricula specific, but we want to teach the base module in data science, some methods, and one specialization area. And then the right pillar is more professional practice and elective courses that you can have, plus finishing, of course, with a thesis or project. In the base module, we teach the courses that highlight the need of business understanding as well as data understanding. And then the data engineering parts, the AI parts, machine learning in there, and also the deployment environment, including the social aspects, legal, ethical background, especially now that you have the GDPR in place. Not every data science project that you would like to do is not ethical or even legal. So we want to go in this broad overview that different components of data science aspects are taken into account in the curriculum. And once you have this kind of background, the broad background, then you can specialize in the business area, or quite opposite, into the humanities, digital humanities, or social sciences aspects. Although in the social sciences, you also have the economics and this kind of understanding the society that has, of course, close link to the business side as well. And the third specialization is in life and natural sciences. This includes health, data analytics. It includes biological data analysis. It includes neuroscience or remote sensing, for example, from the satellite images, understanding what's going on the planet Earth, or vice versa to the astronomy. So these are the three specialization areas where we want our students now to specialize, and hopefully the collaboration with these different units at the university, because university has a broad set of faculties and institutes. So these can be done in the joint collaboration with these areas. The first year's intake, actually, we are very happy that the bottom red and yellow are the students who came from the computer science and statistics background, and you can see that only 1/3 roughly comes from computer science and statistics background. All the other degree programs that they had previously are physics, psychology, mathematics, geography, economics, and the other. So these are the ones where you can have only one or two previous, like single individual with that background. And this kind of cultural mix helps data science curriculum to also succeed, that there are people with the implementation skills, statistical skills, but also the business analysis skills from the given the previous background of the students. In the computer science, you can specialize in AI. So that obviously nowadays means neural networks, understanding of, for example, computational neuroscience. All the natural language processing nowadays, like machine translation, are machine learning based, or big data management. So these are the specialization areas in the AI. And everybody in computer science will be taught in algorithmics as well as machine learning. So also those who specialize in distributed systems or theory side, for example. Conversion masters, we are introducing first year the part-time curriculum version, where you don't need to study as fast as the day program. So it will be like half speed education that you can go through with standard time would be 3 years. But you can of course, you can do it faster if you can, but 3 years would be the expected graduation time. And that reminder, that was the degree program where you did not need to have any prior IT background. So there will be the programming basics would be taught, the database basics would be taught, introduction to data science, introduction to machine learning, data engineering, all these topics will be taught. So you can act as analyst yourself to some extent, or you can interact with the companies who deliver such projects for you. Now, invitation to the companies who will be hiring students out from these degree programs, of course, is that in order to get you to be known to us, the students, you have to be also actively participating in these degree programs, delivering the courses, helping the courses to deliver good education. For example, you can provide good data sets, case studies, you can provide challenges that students can take up, competitions, professional practice offers. So these are the main preferred ways how you can get students at some attention towards your company, or if you want immediate, deeper linkage, then industrial master's program is there that would link company, university, and student in trilateral agreement to work in the benefit of the company, solving the company's tasks during the master's degree. And career day, of course, just telling the students what is your company about, what kind of career options you would have. We are also delivering massive free education, massive online courses. One that is just beginning is on the AI. Elena Sugis will be actually running this course. So you can go to the mooc.ee website and look at what's coming up, and there should be opportunity to register now to the course of AI, 3 credit points worth of introduction. We are located in the nice and modern Delta Center. So those students who come here have very good facilities for collaborative work or online remote work, as we all do now. We have sufficient compute centers, compute power in here, so we can do also big data projects in here efficiently at the university. So that means basically that we can collaborate nicely, set up collaborations in between students and companies, and offer a great opportunity to these studies. You see the photo in here, just next to the river Emajoki in Tartu city center. On the right picture, there is on the background, you can see the university main building and the whole Tartu city center, old town on the background of the Delta Center that is at the foreground. And this is our home where we teach these students. Thank you, and this wraps up my presentation part. There are some email contacts by which you can contact us if you're interested to set up collaboration on from the companies to the cs.business or just to the institute. Just drop an email to unit.cs@ut.e. Thank you.
Thank you, Jak. It seems like our students really becoming multi-skilled, like a Swiss Army knife with everything.
Not everything. They have to be. I think it's important not to say that they do everything, but they need to do one and two, well, at least two things.
Okay.
And once you do two things, you can more easily transfer it to the third one. So then you understand that, oh, this is how I go from this to this, right? This is important.
Okay.
Yeah.
So we have a few questions here in the chat.
Please.
Is it possible to get enrolled in software engineering master program with an MBA business background, but no IT background?
Software engineering intake, Marlon knows better those criteria, but software engineering actually requires software writing skills before the program.
So it's challenging.
So in the motivation letter, there is usually they ask for, show me the repository where you have your own code. Does it look good? So there is some programming skills already required. But in some of the other degree programs, we are trying to reduce that. In the conversion masters, no expectation. And in data science, we have something in between.
There is also a question about data science program. Currently, it's only in Estonian, or some people without Estonian knowledge of Estonian language could also participate.
The degree program officially is in Estonian, even though about half of the courses will be taught in English. But yes, there is Estonian requirement at the moment. We contracted with the Ministry of Economic Affairs, and these were the requirements. So we haven't even started discussing whether it should be changed in the future. Yeah.
And people are also asking where they can find more information about the programs and about conversional masters as well.
It should be found when you go to cs.ut.e and intake. Admissions, I think admissions is the correct link on there. If it's not, then drop us an angry email and we try to make sure that better information will be there.
Okay, so I'll just ask from a pure student perspective. If I'm coming to study something, I probably would want to have practice. Is there any arrangement with the companies that I would have an internship or something like this? Do you collaborate with that?
Yes, so last spring when the corona hit, then our industrial masters program took a backlash hit, but we are reviving that now. So we are opening up to the companies again to have, it used to be 1.5 year program, but now we are opening 1 year program, so that from the summer to the graduation, you would be participating in this industrial masters linkage program, and that would deliver. Well, our idea is really that companies help to contribute to your scholarship, so that you can actually study and study kind of for free. You can live, and you don't need to go to the employment next to your studies. So it's a combined thing. So we are expecting companies and student interest, of course, towards this kind of agreement a lot.
Is it difficult to finish conversional master's program?
I think what happened is that we had relatively low graduation rates previously, but I think it's motivated by two things. It was full-time program, so the tempo was very high. So many people were not able to put that time in that speed. And the other thing is that the prior requirement was the previous degree. So people already had masters, many had PhDs, some had bachelors. So we think that some consider that I don't need another degree, I just wanted to learn some new skills. So actually the graduation rate was relatively low compared to the other programs, but we hope that that this would increase, of course, over the time.
And if I'm an IT student and I want to learn more about about business part, where should I go?
Well, in our building in the Delta, we have business and economics in here. All the courses that are on that side should be available in here. So university is a wonderful place. You can pick almost any course, and you can register there at the right time. You can grab almost any course. You can study and absorb as much as you can in that period.
Well, thank you very much.
Thank you.
Thank you. I will take over from here, and I will take the pointer as well. So
please.
Let's do this. Actually, Delta is, which Jak has advertised, is a really cool place. I wish when I was a student, I would be able to study in a place like that. Okay, I'm the next presenter myself. So, and I will tell you today about the opportunities of quickly catch up in the fast-paced, moving, developing field of data science and artificial intelligence. So we know that the technology is pretty much everywhere in our life. We use it. It transformed our own life, our habits, and the business, of course. So in order to be successful, you need to understand this technology. I personally think that there is a really cool, large amount of technology out there, and there are practical applications. But the problem is that there is a gap between them, and sometimes people don't know how to bridge this gap. And I really would like you to do it. Sometimes, not sometimes, but you're aware about the existence of data science and AI and things like that, but you don't really know how to apply it to solve your business question, or maybe you don't know how to select the right methods, or for the analysis, or you're not sure how to plan the data science project, or where to start from. And on top of that all, we are all super busy, so we don't have time to study and attend time-demanding study programs. And in the Institute of Computer Science, we feel for your pain, and we will offer you a solution by using continuous learning, continuous online learning. So in fact, we have two solutions for you. First solution is called Data Science for Business, and another is called Introduction to Artificial Intelligence. These are online courses, and online courses that were put together in the collaboration between the academia and the industry. And then from academia, we have a number of scientists who specialize in different data science and AI domains. And these scientists are from the Institute of Computer Science and the Institute of Technology. And of course, industry experts about whom I will tell you a bit later. So it all sounds cool, right? But we are usually tuned to our WIIFM. What is it in there for me? I don't know which course to choose if I need it, and so on. So I think that if you're an employee or a manager in a business enterprise, then the course Data Science for Business will be the right place to go for you. So what it is, it's a 4 weeks long online course. It's in Estonian. And this semester we will take, this year we will take maximum up to 400 participants in this course. So why should you care? You will, by the end of the course, you will learn, you will know most important data science concepts and applications in various domains. You will understand the possibilities and limitations of data science in business enterprise. You will be able to distinguish between different techniques. I don't know, say, what is machine learning? What is business analytics? How do I visualize data? What do I need? How do I collect? So you will be able to plan a data science project, and you will also learn the best practices of how to collect and organize your data. And by the end of the course, you will know where to pay attention to, and also how to avoid the most common mistakes. And of course, the benefit or the really cool bonus to it is that it's all for free and you can study it at your own time when you like it. So every week during the course, we open study materials, which consist of some reading and some videos that you need to watch. Then they are followed by the test. To illustrate some practical examples, we have in Google Clubs, we have notebooks, Python notebooks. We usually don't require programming experience, but if you have programming experience, you can run these notebooks and analyze, like perform example analysis. Also, important thing here is that you will try out to plan a business like data science project with your own business question. And during the course, you will get 2 feedbacks from your fellow course participants on your plan. So you will give you a framework, how to fill it, and you will execute and submit it. This is how the 4-week program looks. And in the first week, we will get to know what is data science and this application in business, what are the CRISP methodology and the best practices in collecting and organizing the data. On the second week, we will dive deeper into the different types of analytics, like say descriptive analysis. We'll perform descriptive analysis, then predictive. We'll learn about machine learning and learn how to report the results. And starting from the 3rd week, we will dive more into specific areas of application where we have guest lecturers who will tell how they apply data science to solve their problems. Let's say we'll talk about chatbots, about recommender systems, about some predictive monitoring, and so on. And these lectures are given, like mini lectures, they are given by industry experts. And so on the 4th week, we will also speak about roles in data science project, because quite often when you see a job offer, you don't really know this, like what are they looking for, because the position is called data scientist, but we want to distinguish between data scientist, data analyst, and machine learning engineer, data engineer, and so on. So this you will also learn in the last week of the course. And of course, it's important to know about data regulations and ethics. And in this last week, we speak about GDPR and other data-related regulations. So here I promised you to show our industry experts. You can see that there is quite a number of it. Markus, you have seen already today. And yes, there's a variety of companies like Alpha Blues, Mind Titan, there is Klaus, and many more. In the end of the course, you will get the digital certificate that if you need it, so you can show it at work. It's always good to know what other people think about it. Do I need to take this course or not? So here I show you some examples of feedback from from the course that we ran in autumn semester. And first question is, how satisfied are you with the course? So you can see that the respondents are either very satisfied or mostly satisfied with the course. And also nice feedback results, which was very pleasant to see as an organizer, is that this course actually expanded people's interest towards data science. So I'm really happy about it. The registration for the course will be opened in the beginning of September. So mark your calendar now and keep looking for the updates. But basically, yes, 1st of September, we will open the registration. Another course that I wanted to tell you is if you are really a tech savvy, if you want to dig in more about the artificial intelligence, neural networks, and things like that, then the Introduction to Artificial Intelligence course is for you. Last year, in spring, there were more than 2,000 people registered for the course. It was crazy. So the course is 8 weeks. It's free and it's also in Estonian and fully online. So this year we will take maximum 1,000 people for this course. Yeah. Okay, by the end of the course, you will know most important AI concepts. You will understand AI terminology. You will demystify AI, let's put it this way, because you will understand what AI can and cannot do. And you will get familiar with AI applications in different fields. And also, sweet bonus, is for free and at your own time. So what you will learn, the topics that we are going to cover in this particular course is more related towards machine learning, neural networks, and deep learning. And the first couple of lectures will be introductory to get you to know, understand the concepts. And then the rest 6 weeks, we will be diving into specific areas of applications like image processing, self-driving cars, natural language processing, business analytics, human-robot interaction, and AI applications in medicine and healthcare. And also we will talk about the ethical aspects of using AI. So the studies are organized pretty similar to the previous course. Every week we will open some study materials, then you have to take a test and work through practical examples. So the practical examples are, as I mentioned before, are fully online. They're provided in Google Cloud, using Google Cloud platform, which means that you don't have to install anything on your machine. We also wanted you to get some flavor of how AI is applied currently by Estonian companies, and we asked industry experts to share this information. And so you'll get to know how it's applied in Veriv, Starship, MindTitan, Milram Robotics, Stack, and Swedbank. Also, additional feature, which a lot of our students like, is that you can actually submit your direct questions to the domain expert, and we will forward them. We will ask them from these domain experts in the form of an interview, of Q&A interview, and then post it online. Last year, we spoke with Jan Tallinn and with Christian Korjus. Both of these interviews were really interesting. I suggested to watch it. They're available on the web. So by the end of the course, you will also be able to get the digital certificate. However, if you want to use these 3 credit points in your future studies, you can take a test under controlled conditions, and then we will you can use it afterwards. Also here, probably you would like to know if it's worth to take this course. So here's the feedback and how satisfied our students were with the course. And here we can also see that the majority of people are actually either very satisfied or mostly satisfied. And on the lower graph, you can see the topics. And here is the machine learning and machine vision and self-driving cars were top 3 topics that people liked the most. So good news for you that if you're interested, registration is right now opened. We will close the registration on the 28th of February, and the course itself will start on the 15th of March. So rush to the register. Here you see the link, and you can also find this information on our webpage. And yeah, let's get in touch. And if you have some questions, then please send them. And yeah, thank you very much. And right now, we will have a little, okay, we are preparing for the panel discussion, which will take place in a minute. Grab them by the sleeve and ask this question. So I will start myself. We have discussed like many different aspects of data science in business, but what is the most, how do you see it in the future? What is the most, what are the trends in development, data science developing for business?
Well, it's something that's definitely happening more and more, and like it's still being ironed out right now, is like different approaches to automated machine learning. And I see that like a lot of businesses are really hyped to use it, but in many ways it doesn't really work anymore or work yet. Or like it works, but it works in really narrow applications. So, but because everyone is developing it, and a lot of resource and a lot of time is being put into this, and the will to use it is there, then I think that like in future, maybe it's going to be 5 years, maybe it's going to be 10 years, but I think it's going to be used more and more, at least for the simpler kind of problems.
You mean the one where you try different things and automatically pick the one that works?
Yes. And for like simple problems where I can upload a CSV and define that this is my problem, this is what I want to predict, and it'll work in some cases. And I think those cases will expand.
And the big players are also developing this AutoML applications, or big and small players, everybody are developing this, and it becomes easier and to test your use case with real data. You don't particularly have to be data scientist in all these cases, because
Do you do some kind of parameter sweep through the search space as well, or different network architectures if you apply deep learning?
Yes, definitely. I mean, it's like when you do it generally, like when you get the biggest win from working with the data, not working with the model. But like when you realize that, yes, this is the approach I'm going to use, then yes, you do. You also definitely parameter sweep if you have a lot of resources available, then also architecture search. But yeah, I think that like this is really resource intensive right now. It's super expensive. And also for most problems where you need a neural network, you can't really feed a CSV into it. So I think that also data processing is a bit more complicated. But I think that if a lot of intelligent people try to come up with solutions for this, then in time they will. And I just think that the will and the resources are there.
In case you have some client with sensitive data, how do you convince them to share the data, or what do you do? How do you solve their problem?
Do we even? I mean,
I don't know. It's a question to you.
In some sense, like I cannot convince anyone to give me their super sensitive data, and also to me it's a liability, because like if it leaks, it's my fault. Nobody will ever work with me again, because this will be publicized. People will get fined. So usually, if there's really sensitive data, they also have specialized like sections in the company who are responsible for keeping it safe, and these people will never allow it outside. So usually there will be like the need is what convinces them. I may just help them understand that the need is there and that the solution is one data transfer away. And usually these sections will come up with those solutions themselves, like the sections of the company, departments of the company.
And if you want to show that your prototype works for the data, what do you do?
Well, it really depends. Like I think that one of the strictest that we have worked on is the tax authority. And in that case, there were like intensive background checks, a lot of different contracts, like physical hardware that was moved on their premise and put in an air-gapped server rack. So it can get like, it can get really complicated and annoying, but if there is a need, there is a way.
And data itself, I think in most cases are already anonymized, let's say purchase information, or you just have these IDs, but not you can't reach the particular persons there. Staka has also extensive research on this personal medicine field, where we have personal health records. Jaak can tell more about it, but there we have complicated contracts in place, where we and how and what measures has to be there to process that data. And yeah, it's complicated in many ways. But today you have to follow these GDPR rules and have a common sense. And in many cases, it's not so complicated. The business data almost, I think that is in general, I think it's have to be handled very carefully.
Yeah, of course. Jaak, do you want to comment on this? How to comment?
No, but here we probably get into this, what is current research age, where the current standard practices at the companies. So modern is not here, but the research age that they are trying to do is that when you start analyzing this data in business processes, etc., to also plug in that differential privacy or all this K anonymity, that no query should reveal less than one, but also the difference should not deliver less than 5, but also the difference of the query should not be very small. So all these things will be built on top of the mining tools as well, eventually. So the first promises are there, but still it would have to be in the safeguarded environments, definitely.
Yeah, I think like right now it's even super complicated to convince anyone to try or even think about ShareMind, which is an actual product. And like getting people to try and set up some methods that are like half research, it's hard. It's easier to get a server to an air-gapped room.
We have a practical question here. Like, how could someone convince their boss to make decisions via data science?
Like, I think
the data shows that you should do this.
I think the keyword here is to, like, if the boss is a business person, you just tell them that, do you want to be data driven or not? Because this is the hype word right now. Everybody wants to be data driven.
Maybe it's the fear. Maybe it's the fear of losing out. That matters more. That if you don't do it now, you will be left behind in the competition.
I have another solution for the problem, and it comes from this really the essence of the data science projects, that I think the barriers are really low to start actually the initial experiments. This early phase of the project is more related to the business analysis and understanding the data, and these type of sprints or project sprints maybe last, the duration of these sprints is maybe 1 to 2 weeks. And I think if we put it even to the money-wise, it means maybe 5,000 euros, depending on the complexity of the problem. But the result of this initial phase of the project, of course, is answer, is there any point to go further with building the real system or analyze further? And I think it's feasible already to the most of the companies to try out what data science can do and how you could benefit from data science.
What I experienced that when we did this retail data analysis, actually the ones who were kind of threatened were the people who were the ones who were supposed to know everything, and they probably also felt a little bit threatened. Or if data science, this is example, but I knew that already. But this is not the point, because you have to go through the supermarket, all the 10,000 products, and you cannot do the same mechanically. So they did not necessarily understand the value of automation of this scale versus, yes, I know this. It doesn't tell me anything new. But it's kind of the humans who may feel threatened, rather than understanding that it's actually there to support them to be even better.
But I think that actually, when someone says data science, then I immediately start thinking machine learning, but that's not like all of it. It's also like descriptive data science. Yeah. So like if you start from that, then Kalev exactly pointed out that like starting with descriptive data science is actually quite simple and doesn't cost so much. Like you could, like descriptive data science, Tableau is almost there, right? Like the people who deal with business intelligence, they're like halfway there. So this one is a small step. But yeah, moving on to like how to convince someone to make decision based on what machine learning model tells them, that's a tad more complicated and a tad more expensive as well.
Good question. I'll follow on that. So how I'm, as a company representative, should make a decision whether to hire a data scientist or adopt some software that perform automated tasks? Which is the benefit in which case?
When you say use some software, do you mean like for automation, use some RPA, like robotic process automation, or you mean like some AutoML thing?
I understand.
It depends on the scenario. But
when should you hire the company or rather than
a person,
just buying the Tableau?
Yeah.
I think that like the companies that do business intelligence that use the law, they're a completely different matter. I think that like it's the same thing actually with machine learning and also business intelligence. If it is something you think that you will need for a long time, like it's not that I'm building out one feature and I'm going to maintain it afterwards. I'm going to do business intelligence until the end of time, as far as I can see it. Then you should have people internally who can manage the flow and answer your questions. What I see often is that like people need machine learning for like developing a single piece of software, like I don't know, a dictation machine for a specific type of audio, and after that it's just maintenance. And if you get a team of data scientists for that, then after 6 months they have nothing to do. But like with business intelligence, they probably do have something to do because like it's an ongoing supporting activity. Or the other case might be that if you have a roadmap of machine learning solutions that you want to build, then yes, probably also like it does make sense to have people on board.
Kari, you wanted to add something to that?
No, I think they basically covered. I think it depends on the let's say how data intensive is this decision making in the company, and you could hire. You need to hire any analyst or data scientist for doing ad hoc analysis to just map the as is situation in the company. But if you have continuous business process and this is decision making is complex and data intensive, then you probably maybe it's a good idea to build. I avoid the word machine learning. It can be rule based also, but it depends so much. I mean,
I have an idea is that in data science, one of the skills of data science is like to make research, kind of.
Yeah.
Yes. So, and this important skill is important when you have some unknown problem, not standardized problem, right? Something that has not been before, something that you have to map, you like research more. So in this case, data scientist would be more valuable solution.
True, but like if you think about a large company that has a lot of different products and operates in a lot of different countries, then the sheer amount of data and the sheer amount of variables actually means that the whole field is research. If somebody asks you a question like, should I launch this product in this market? Then like saying, getting to an yes or no and actually having a basis for it actually requires you to not just be generally intelligent and have some stats knowledge, but you have to be inquisitive, you have to be analytical. It's actually a hard question to answer in these cases. And in that case, it might even be that you need someone who not only understands the company well, but is also knows stats well, for example, so they can interpret what they see.
But I also think that the bigger the company, the clearer it is that it's only one task that you need to do. After this, there will be another task and another product upgrade. So in the big companies, you can always take this knowledge and take to the next thing. But what is also important in that case is that you are still manpower limited because you can't hire infinite amount of people. So it would be still good that there are knowledgeable people approach companies who are specialized in some offerings and help in some cases. So some knowledge inside, some knowledge from outside, be it from the specialist companies or be it from the university even. But some core things have to be internally as well available, right? So they know how to purchase from the other vendors or team up with the university in that case, for example.
We actually have like a few partnerships like this in some sense. Like we have partnerships where we are the core machine learning team in a company basically, so that they don't need someone continuously. They can maintain stuff themselves, but if they need something built, we can build it for them. And if they need some consulting at some point, we can do it for them. And at the same time, like by working with us and by like learning how this stuff works and how to maintain this stuff, they also now know how to order the stuff, like how to go to someone else and ask for something.
And referring to your presentation, Jaak, that the data science, the background of these students is very different, and they are not just IT specialists. One of the bottlenecks of doing a business with data science is this domain knowledge is very often the bottleneck of understanding the customer, understanding the business, because it really affects how the data scientist is approaching to the data and tackle these problems, business or use cases there. And when junior level data scientists are coming from the university, they lack this life experience, so to say. and it's really hard then. And then we have to rely on the customer or the very strong, good product owners from their side to teach basically our people to understand their business. And if you were saying that we have maybe too big variety of the different projects, it is the problem, because at one point you need to focus. I don't know, Markus, at your company, you have selected some of the business domains where you dig deeper in. Do you feel the same thing? With my data scientist, I really feel that sometimes we lack the good business knowledge, and we need to learn much more and listen to the customers. What are their real needs there?
It's a really good point to listen to the customers.
Oh, it's always easy, but
because they will tell you what they need.
Yeah.
But life experience comes with the age. So we add 5-6 years to the age of every student during their master studies. Bachelor's plus masters.
I'm afraid they won't graduate this way.
I expect more and more.
Well, 3 + 2, it takes 5 years to study. So we add 5 years to their age.
But I think that like getting this domain knowledge, getting people from different domains that have enough domain knowledge to actually be knowledgeable in enough like areas is impossible. So yeah, you either have to like focus, or like what we have done is that we do focus in some specific areas where we also understand that the solutions are repeatable. But a lot of data science and machine learning projects are ad hoc in a sense that, okay, it's still audio, but the domain of the audio is different. In that case, what we also always like very put huge amounts of emphasis on with all our clients is that we need 2 people from you at least, and one of those is like the business owner, in a sense that they are they can coordinate, they can organize inside the like the larger organization, and they like push us through. And at the same time, there needs to be a product owner who is an interface to us. So we teach them about machine learning, they teach us about the project itself. And this enables like a really good collaboration, even in new domains. But yes, you also always have to check yourself, because like if you don't know enough, then you start making stupid assumptions without even realizing it.
We have a question here related to that. What soft skills are critical for business data science development?
It would be really
soft skills.
Soft skills. Exactly.
I think that the thing that I feel that I am lacking the most, that would be really required, is like not being introverted, because like you need to. I sometimes I don't answer emails because I just putting it off forever.
Overloaded.
And no. It's just that the thought of writing an email, communicating with other people, makes me anxious. And if you do that, then you don't communicate. But then when you don't communicate, it's all going to break down.
But you know that it comes with your genetics, so we cannot change your genetics so easily.
You can practice.
You can practice a little bit, yes.
Like,
but still, something is in our genes.
Chatbots, right?
That's why.
You see.
That's why I developed MOOC courses.
But I think one important thing is it's really hard to say that there is no soft skill that you can learn in one course. That we take 1 credit point course for presentation skills. It doesn't work like that. It has to be throughout. But I think what university does, and in this data science case, I think kind of is that we are always in the new territory. And that's exactly what universities have been doing in their past research. It's not that you learn the textbook, but it's actually to learn going beyond the textbook. You always have to go to the unknown territory. And this is something that that universities should do, should push students, everybody, to this unknown territory to see that they can cope, they can actually absorb the information, and they can come up with their own research, tiny bit of research, and solve that problem. So this being able to cope with this unknown territory, I think is very, very important. That's why the research part is important at university.
Yeah, I totally agree. And as much people as we have from Tartu University, that's one really nice thing about people from there is that, like, say one project ends and you need someone for another project, but it's a completely different domain in some sense that you were working on audio, now an image project ready for you. And it's like, would you like to work on some completely different stuff that you don't know much about? And they're like, yes,
of course.
it's so interesting. Let's get at it.
Yeah, I think this is
Jaak is training people.
but then I would oppose to the, I mean, really doing stuff. I mean, really completing these projects with 85% of the success. Is it now soft skill or not? But it really means sometimes to honestly say no, or really be practical and manage the expectations. And is it soft skill or hard skill? I don't know. It's probably soft skill because it's psychological in many ways, that your skills as a project manager to manage the expectations of the customer towards the working result or whatever. And that's something where, again, I mean, data scientist, his or her mind is a kind of an explorer or researcher, and they are curious by their nature, and they would like to test everything. But at a certain point, they have to draw a line. That's enough. And move forward.
But then always playing safe is something that is it's like medical doctors. The best medical doctors or surgeons, for example, are not necessarily the best with the best outcome, that the most people survive after the surgery. Why? Because actually they get the hardest cases. They cannot do if you only are betting on the safe projects and not taking the hard projects, then of course your success rate would be higher, but the top specialists would be taking also the hard cases. So it's not that you can easily go safely beyond this 85%, because if you go to 100% success rate, then there was nothing very special about those projects.
Yeah, but I think that Kalev is right in that part, that often you do have to say that no, this is not a good idea, and not only because like it's mostly not because it's not doable with machine learning, but more like it's doable, but it's going to take me 2 years, and it's not going to be worth it to you. And then they're like, okay, it's definitely not going to be worth it. And if you manage expectation in that way, then this is something that you have to do. But every once in a while, people do come along to whom you tell that this is super complicated. I don't really know if it is doable at all, and it's going to take a long time. And then they say, yes, let's go do this. And these projects are just a joy, but they don't happen often.
And what we do in stock, that we have so different these projects are. Some of these are kind of really close to the kind of fundamental research or experimental R&D, such as your personal medicine projects very often are. But then again, you have something very practical like this recommendation system, and there you can't fail. You have to deliver. You have to put the budget there, and you need to deliver. Otherwise, it won't work. And then you have all these phases between there, like how much you can experiment, how much luxury you have to play with the data.
But there is there still is a lot of vagueness. Like these recommendation engines are a nice example, because like you try, it's easily understandable to the customer, like what it is, what it's supposed to do. It's going to increase the bottom line by X percent. Then I'm going to ask you, what percent can you promise me? And like in your head, in your heart of hearts, you know that you can't promise anything, but you have to promise something. This is where it gets complicated.
How to get
you have to promise a little bit more than what your cost is, at least.
Yes, that's also the thing. You have to know like what the revenue is to even know what to estimate. But yeah, it's just like with machine learning, it's kind of what makes selling machine learning complicated is that you're selling something that's really vague and asking for a lot of money for it, and it's like it gets people anxious.
It's understandable.
Yes, I would be anxious.
Yeah. Yeah. So besides business and medicine, is AI used to inform public policy making, or is there any trend into that direction?
The mileage can vary. So even now in the corona times, so when you predict something, then how much AI there is, how much modeling, there are relatively simple things that you can do. Of course, it affects the policy making, but it's hard to say what it. Now we would need to start defining what is AI actually. But one part of the AI is this machine learning, but the other part is also optimization. So optimization tasks. Of course, you can build the optimizer for something and try to optimize some parameters, right? Of course, it should be able to affect some policy making. The question how to deliver. which questions are being asked, which questions can be solved by these kind of approaches, and whether somebody who makes the policies, whether they would listen.
Is it a matter
Some
of
decisions
safety?
some decisions might be even correct, but might be politics and policies are quite tricky because it's there may be collateral damage to the politicians to make some policies that might even be good.
Okay, I see. I have like few questions posted about the courses. People, we will. So you're asking about whether the course will be data science course will be in English. If you're asking about MOOC course, that at the moment it's going to be in Estonian only. However, if I see that there is a lot of demand for it, then I might consider. So actually, there are a lot of possibilities of learning about such things as data science and AI out there, like using Coursera and Udacity and so on, but there has not been a course in Estonian. So that's why we created this course. However, if you are insisting, and there will be a lot of people who will write me an email and say that, yes, please do it in English, then we will do it. And the other question was about, is there any plan to open MOOC courses about machine learning applications on quantum computers? And it's possible. You got your answer.
The demand at the moment would be quite limited because nobody knows even the answers, how much there will be again. Such seminars are very specialist. You can go 1-2 students with a professor. It's not a massive course, I guess.
Yeah, but I will make a small remark that actually right now, if you take our courses, you can use it in the university studies as a free choice subject. So, and from the University of Tartu, and also you can do it in other universities if you consult with your study department. If they allow it, then you can use it there as well. So I hope that answers your question. If not, then write me an email. Okay, and I think we are running out of time today. So I can speak forever. It's okay. My math teacher said that if to put the crocodile near me, I will talk with him as well.
Like you have at least you have at least one professor here, and academics can always talk forever.
I like.
I don't talk much.
Don't you now?
Oh. Okay.
Introvert as I am.
Yeah, where you see.
Influenced by the other.
What is the research frontline of data science in your opinion? You are referring to something liquid neural networks recently in the social media. I remember I was reading the article.
I think that was somehow self-adopting architecture in there. No, I'm not closely following the neural network side of the.
We were all.
Yeah. So that's all.
Okay.
Okay, and
thank you, everybody.
Thank you.
Tune in for the next data science seminars.
yeah,
You will
the
get
next
the announcements.
yes, next data science seminar will be on the 31st of March, and it will be about hyper performance computing. So stay tuned, and hope to see you next time. Bye bye.
Bye bye.
Goodbye.